It's time to get your arrows popping. Ladies and gentlemen, this is Mr. Whitt with Fort Bend Tutoring, and today we have a special video created just for you called Solving Quadratic Word Problems. And just so that you'll know, in the background you may occasionally hear some popping. That is fireworks going off in the background because it is New Year's Eve. And if you'll be so kind as to press that subscribe button, go ahead and click on that, please, as well as the notification bell so that you'll be notified when we're uploading new and fresh content. I will appreciate that greatly. So let's go ahead and move on into the video. As we are covering quadratic word problems, we're going to read the word problems. Depending on the problem, we may need to draw a figure. We will definitely organize our data. We'll then label our setup, whether it be a table or a diagram, and we will definitely be analyzing the given information and solving the word problem. So therefore, we got 1, 2, 3, 4. You might as well say 5 things that we will be doing as we attack quadratic word problems, guys. So without further ado, we have 8 problems to show you in this lesson, and let's begin with problem number 1. In problem number 1, it says when twice a number is added to the square of the number, the sum is 3. Find the number or numbers. The first thing I'm noticing is that we don't know what this number is, so we're going to give it a variable. I'll call it the variable x, and I'm going to label this and say that this variable x represents the number. So the next thing we'll do is translate this into an algebraic equation. It says when twice a number is added to the square, so when twice the number is added to the square of the number, the sum is 3. So that means that we're going to be adding twice the number plus the square of the number in order to equal to the number 3. And we know that finding the sum involves us adding more than one number together. In this case, the value 2x and the value x squared will be combined together to give us that sum. As far as finding the numbers is concerned, we'll need to solve this quadratic equation. And the first thing I want to do is rewrite this equation in the standard form of a quadratic equation, which is ax squared plus bx plus c equals 0. And how do I get there? I'm going to go ahead and subtract 3 to both sides of the equation, and on the left side of the equation I'll be writing the result in descending order of the variable x. So I end up with x squared plus 2x minus 3 equals 0. It's at this point that you can solve the quadratic equation using your preferred method and strategy for solving quadratic equations. That means that you can use the square root property, completing the square, the quadratic formula, or my favorite, the zero factor property. And that's what I'm going to do here. I'll be looking for 2 factors of 3 that'll subtract to give me 2. In that case, my factors of 3 that I'll use is 1 and 3, being as though 3 is a prime number. So I'll open up 2 sets of parentheses here, like so. Make sure it's still set to 0, and I'll have my variable x and the factors of 3, which are 3 and 1. There goes those fireworks, guys. Next, I'll be using the sign of the middle term's coefficient for the sign of my largest factor. So that means that out of 3 and 1, 3 is the biggest, and 3 must be positive. Because I'm subtracting to get 2, I'll need to have the 1 a negative 1. So that's going to give me the signs of my factorization there. Now that I have my quadratic trinomial fully factored, I'm going to go ahead and set each factor equal to 0 and solve for x. So the first equation will have x plus 3 equal to 0. I'll have x minus 1 equals 0, and then I'll solve for each equation. In the first equation, I'll be subtracting 3 to both sides. This gives me x equals negative 3. In the second equation, I'll be adding 1 to both sides, which gives me x equals to 1. So as far as finding the number or numbers that'll make this original equation true, that'll be the results that we see here as x equals to negative 3 or x equals to 1. So we can go ahead and write this as a solution set here. If I can get a good brace going. No, that's a hideous brace. No. Still, that's better. There you go. We're going to use negative 3 and 1 within the, oh no, this is terrible. Oh, that's going to fly. Into our solution set and red box it. That's right, guys. We're going to box up our solution and keep it protected from the evils of the world. That's right. So that completes problem number 1. Let's move on. Here I'll be reminding you guys that Fort Bend Tutoring and myself, we offer paid online tutorials. Just go to our website, fortbendtutoring.com, or WP13math.com to set up a paid online tutorial with me. That's right. That's right. Today. There you go. There you go. Give me all of your money, please. That being the case, let's go ahead and move on. We have problem number 2. That's right. And with problem number 2, it says if the length of a rectangle is 1 foot less than the width and the area is 12 square feet, find the dimensions. So because they're mentioning a geometric shape, the first thing I want to do is draw the shape. So they're mentioning a rectangle. I'm drawing a rectangle. There I go. Okay. It then goes on to say that the length of the rectangle is 1 foot less than the width. This means that I don't know what the width is, but I do know that the length of the rectangle is 1 foot less than the width. So that's going to mean that my length is the width minus 1. So notice that not only have I drawn the rectangle, but I've also labeled the rectangle as well. Because they mentioned the area of this rectangle, we'll need to keep in mind that the length times the width equals to the area of a rectangle. And notice that this information was not given to you within the problem. So they're expecting you to either know this information or be able to find this information in order to solve the problem. So anytime you're looking for the area of a rectangle, just know that the formula is length times width in order to find out that area. They did inform us, however, that the area of this rectangle equal to 12 square feet. All right, so we'll be keeping that in mind as we move on to our next step in the process, and that is substitution. We'll be substituting each of the values in this equation for the area of a rectangle with the information that we were able to get from the original word problem and the values that we were able to translate from the word problem. So remember that we said that our length of the rectangle was going to be W minus 1. In other words, the width minus 1 times the width. This equals to the area, which we know is going to be 12 square feet. So this is going to be the equation that we'll use in order to solve problem number 2. From here, I'm going to go ahead and distribute and then get my arrows popping. That's right. That's what I'm going to do here. And W times W gives me W squared. W times negative 1 is negative W, and this equals to 12. From here, we want to put the equation in standard form of a quadratic equation. So that means that I'll be subtracting 12 to both sides of the equation. And then I'll be rewriting this as W squared minus W minus 12 equals 0. And now we have our equation in standard form of a quadratic equation. There you go. So from here, I'm going to be trying to use the zero factor property. That's right, my favorite. Once again, if you want to use complete and square, you go right ahead. If you want to use the quadratic formula, have at it. But for me and my family, we like the zero factor property. That's what we like. And I'll be looking for two factors of 12 that'll subtract to give me 1. And looking at the factors of 12, which are 1 and 12, 2 and 6, I'll be using 3 and 4 because the difference of 3 and 4 gives me that middle term's coefficient of 1. So I'm going to open up 2 sets of parentheses here. Make sure it's set to 0. I have my variable W, and I'll be using 4 and 3. The sign of the middle term is going to be the sign of my largest factor, which means the 4 must be negative. And because I'm subtracting to get the 1 middle term, I'm going to have a positive 3 here. Now I'll be setting each one of these factors equal to 0 and solving for them. So I'll set up the first equation as W minus 4 equals 0, and the second as W plus 3 equals 0. And then I'll solve for each one of these equations. I'll begin by adding 4 to both sides of the equation on the first equation here, to end up with the width being equal to 4. And then with the second equation, we'll subtract 3 to both sides to find that the width equals to negative 3. However, our width can't equal to negative 3 because we're dealing with a rectangle here. Your dimensions are not going to have negative values. That means that this solution that equals to negative 3 is extraneous. We can't use this because it won't work in the original problem. Therefore, can't be used. So that means that your width here is going to be 4. And since they're asking us for the dimensions of this rectangle, remember that you always want to make sure that you're answering the questions of the original word problem. And this word problem just didn't ask us for the width. It asked us for the dimensions. So they want both. They want to know the width and the length of this rectangle. So that means that my width here will equal to 4 feet. While the length is going to be 4 minus 1 to give me a value of 3 feet. Okay, so if we were to write this out, we can simply say that we have a width of 4 feet and we have a length of 3 feet. All right, and these will be the dimensions of our word problem for problem number 2. Red, box it. All right, guys. That's problem number 2, and moving on. In problem number 3, we have when 4 is subtracted from 9 times a number, the result is equal to twice the square of the number. Find the number or numbers. All right, so in problem number 3, I don't know what this number is, so that'll be my variable. So x equals to the number. There we go. And after labeling that, we can go ahead and translate this into a quadratic equation. It says that when 4 is subtracted from 9 times a number, so I'll write this as 9x minus 4, the result equal sign is equal to twice the square of the number. So that means it's 2x squared. So this will be the translation of the word problem for problem number 3. Once again, when 4 is subtracted from 9 times a number, that's what we have on the left here, the result is equal to twice the square of the number. So that gives us 2 times x to the second power, or x squared. There we have it. I want to write this quadratic equation in the standard form. So that means that I'll be subtracting 9x to both sides. All right, and if you guys will permit, I'm going to go ahead and add 4 to both sides as well. You can do this in 2 separate steps, but because I have limited space here, I'm going to go ahead and combine those 2 steps together. We know that these additive inverses are going to cancel out to 0, so that means that I'll be bringing down those are the fireworks, guys. We'll have 2x squared minus 9x plus 4 equals 0. And this is going to be the equation that we can use to solve problem number 3. Because I have a leading coefficient that's not 1, I'm going to use the AC method, or at least my version of it. And that's where I'll be multiplying 2 times 4 to get a value of 8 here. And knowing that my factors of 8 are going to be 1 times 8 and 2 times 4, I'm looking for 2 factors of 8 that will add to give me 9. Well, if that's the case, I'm looking for the factors 1 and 8 because those factors will add to give me 9, which is what I need. Opening up 2 sets of parentheses now, I'll have my variable x, I'll have 8 and 1, and because the middle term's coefficient is negative, my largest factor needs to be negative, and the value of 1 needs to be negative as well in order for them to add to give me negative 9. Because of this leading coefficient of 2, I'll now divide both factors by 2 and simplify it to give me x minus 4, and then any remaining denominators will go in front of the variable, and this will be 2x minus 1 equals 0. Now I'll be setting each one of these factors equal to 0 and then solving for x. So we'll have x minus 4 equals to 0. We'll also have 2x minus 1 equals to 0, and then you'll solve for each one of these equations here. I'll begin by adding 4 to both sides of the equation. That gives me x equals to 4. In the second equation, we're adding 1 to both sides. We have 2x equals to 1, dividing both sides by 2. You'll have x equals 1/2. This means that the solutions to this problem is going to be 4 and 1/2. So as a solution set here, I'll have 1/2 as well as 4. And this is going to be the solution to problem number 3, guys. These 2 values, the 1/2 and the 4, and notice that I did write them in ascending order in the solution set that I have. I put the 1/2 first and then the 4, and now we'll red box it. And that's problem number 3. In problem number 4, it says Marcus paddled his canoe 20 miles upstream, then paddled back. If the speed of the current was 3 miles per hour and the total trip took 7 hours, what was Marcus's speed? So the first thing I notice is that this is an example of a distance problem. So I'm going to make a note that distance equals to rate times time, guys. And you can also write it as D equals to RT for short. When I'm solving distance problems, the majority of the time I like to use a 3x3 table. So let's construct that. All right. Here we go. Getting our table nice and cute. There we go. And I know I'll be labeling the rate, the time, and the distance. Just so you know, each time I use a table like this, the first column times the second column will always equal to the third column, guys. From here, we're going to continue labeling, knowing that Marcus went upstream, and then he also, because of the round trip, went downstream. And I'll use this last row here for a total. All right. So going over the word problem again, Marcus paddled his canoe 20 miles upstream. So the distance upstream was 20 miles. He then paddled back, so that's another 20 miles. So our total number of miles traveled, 40 miles. There we go. If the speed of the current was 3 miles per hour and the total trip took 7 hours, what was Marcus's speed? So we don't know how fast Marcus was traveling, so that's what we're trying to find out, right? So what we'll do next then is we'll state that his speed going upstream minus the current. See, when you're going upstream, the current is working against you. It's actually slowing you down. So because of that, you'll say that Marcus's speed minus the 3 miles per hour from the current that's slowing him down along the way. When he goes downstream, though, that situation changes and the current actually helps him along. So his speed is going to be whatever his speed was plus that 3 mile per hour current. For this problem, this total overall speed does not matter one bit. We do know that the total time is 7 hours, and if you'll manipulate the formula, that is, if I take this distance equals to rate times time and solve for time, you'll see that after dividing by the rate, that time is equal to the distance divided by the rate. And that's exactly how you'll find out these two remaining values in our 3x3 table here. So we'll take this distance of 20 and divide by x minus 3. And then for the second time here, you'll have the 20 distance divided by x plus 3. It'll be these values of the time that we'll use to create our equation. So I'll be focusing on these values right here to create our equation now. The equation is going to be his time going upstream plus his time going downstream will equal to the total 7-hour total trip. Solving our rational equation, I'll want to get rid of these fractions, and I mean in a hurry. So I can do that by multiplying each and every term by the least common denominator, which will be the product of these two denominators. So I'll have the quantity x minus 3 times x plus 3 times that first term of 20 divided by x minus 3 plus the quantity of x minus 3 times x plus 3 times the second term, which is 20 divided by x plus 3. This equals to 7 times that same product of x minus 3 times x plus 3. So this is my equation thus far after I'm showing that I'm multiplying each and every term by the least common denominator here. Simplifying, our x minus 3's will cancel out, so I'll be bringing down 20 times the quantity of x plus 3 plus the x plus 3's will cancel out now, leaving me with 20 times x minus 3, which equals to 7 times, and this x minus 3 times x plus 3, guys, is a difference of squares. So what I'm going to do is multiply that out. In other words, get my arrows popping here. And what you'll end up with is x squared minus 9 after you combine those middle terms, which will cancel out. All right. From here, we'll continue to get our arrows popping. That's right. So I'm going to be distributing the 20s here as well as the 7 on the right side of the equation. 20 times x gives me 20x. 20 times 3 is 60. 20 times x is 20x. 20 times negative 3 is negative 60. Then distributing the 7 on the right side of the equation. 7 times x squared gives us 7x squared. And then 7 times negative 9 is negative 63. And this is what we have thus far. Let's go ahead and combine our like terms. 20x plus 20x gives you 40x. The 60s are additive inverses, so they're going to cancel out, and this equals to 7x squared minus 63. The next thing I'll want to do is put this equation in standard form, so I'll be subtracting 40x to both sides of the equation. Our 40x's will cancel out here, so I'll end up with 7x squared minus 40x minus 63 equals 0, and this is our equation in standard form and without any rational expressions, aka fractions, in it. Now notice that our first coefficient is not 1, so that means I'm going to attempt to factor this using the AC method. And what I know about this problem is that I don't want to multiply 7 times 63 because that's going to take me over my personal limit, which is 100. That's right. If the product of this goes over 100, I get a little fearful of that big number. So what I'll do instead is I'll recognize that this 63 can break up to 7 times 9, right? And because of the initial 7 that we have in that first term and the two factors of 63, 7 and 9, I know that I can find values within this that'll subtract to give me 40. How do I know that? Well, 7 times 7 gives me 49, right? And what's left over? The 9. Isn't 49 minus 9 40? Exactly. So that's what I'll be using to factor this. So I'm going to open up two sets of parentheses like so. And I'll have my variable x and 49. Once again, we got that from the 7 times 7 there. And then the leftover 9 that I had from that factorization of 63. Because the middle term's coefficient is negative, my 49 needs to be negative and the 9 needs to be positive. From here, because the leading coefficient was 7, I'm going to divide both of these values by 7 and then simplify. This gives me x minus 7 times any remaining denominators going in front of the variable. 7x plus 9 equals 0. And now we have this trinomial completely factored. If you want to see more examples using this technique, check out our Factoring Quadratic Trinomials Part 3 video, where I go over how to tackle problems that have a master product that's over 100. All right, scary business, right? From here, I'm going to take each factor and set them separately equal to 0. So we'll have x minus 7 equal to 0, and we'll also have 7x plus 9 equals 0. From here, you're going to set each equation equal to 0 and solve for it. In our first equation, I'll be adding 7 to both sides, and that gives me x equals 7. In the second equation, you'll subtract 9 to both sides of the equation. You'll have 7x equals negative 9, and then dividing both sides by 7, you'll have x equals to negative 9 sevenths. The problem with the second solution, though, is unless Marcus was paddling backwards, his speed should not be a negative value. Therefore, we're going to consider this an extraneous solution, a solution we can't use. So forget about it. And that means that our only solution to this problem, as far as his speed is concerned, is the 7 solution that we have. That means that Marcus's speed is 7 miles per hour. All right, and that's our solution. Red, box it. Just like that, guys. And that completes problem number 4. Continuing on. In problem number 5, Jasmine is flying a kite that is 30 feet farther above her hand than its horizontal distance from her. The string from her hand to the kite is 150 feet long. How high is the kite? So because my favorite cousin is Jasmine, we gotta make her look cute, guys. So we're gonna begin with a head. There you go. Smiley face, because Jasmine is always happy. We don't want to see her sad. She has some nice long hair. And there you go. There's Jasmine. There she is, guys. She's a happy girl. From here, she's flying this kite. Yep. Got herself a nice kite going. All right. And she's holding this string, which is 150 feet long, by the way. And from the horizontal distance from her, we know that this height of the kite is 30 feet longer than the horizontal distance to the kite. So what we've just created, guys, is a right triangle. Yeah, that's exactly what we created. And in continuing to label this, we're going to say that the horizontal distance is unknown, and the height of the kite is going to be x plus 30. That is 30 feet farther above her hand than its horizontal distance from her. So the horizontal distance is unknown, but we do know that the height is 30 feet higher than the horizontal distance. And remember, we did say that the string is 150 feet. So we have 3 sides of a right triangle labeled, and that means that we can use the Pythagorean theorem. Remember, the Pythagorean theorem is a squared plus b squared equals c squared, where c is the hypotenuse, which is the side, the longest side of our triangle, and always opposite the 90-degree angle. Well, it doesn't matter how you label the legs. In other words, which one is A and which one is B doesn't matter. So I usually will just go from the horizontal and then the vertical. So we're going to be labeling x as A, so we'll have x squared plus our B value is going to be x plus 30 squared, and this equals to 150 squared, like so. Then I'm going to be expanding this binomial that's being squared right now. You can't distribute that exponent within, but you can expand it, showing that this means x plus 30 times x plus 30. And this equals to 22,500. That is a result of 150 times 150. From here, I'm going to get my arrows popping here as I multiply these binomials together. And I'll be bringing down this x squared plus 30x plus 30x plus 900 equals 22,500. Just like that, guys. Go ahead and combine your like terms now. You'll have x squared plus x squared, which is 2x squared. We'll have 30x plus 30x, which is 60x, plus 900 equals to the 22,500. Then we'll subtract 22,500 from both sides of the equation here, like so. Bringing down 2x squared plus 60x minus 21,600 equals 0. All right. Now, I don't like these large numbers, but I do notice that they can all be divided by 2. So that's exactly what I'm going to do next. So dividing each term by 2, like so, guys, we'll have x squared plus 30x minus 10,800 equals 0. You'll be looking for two factors of 10,800 that will subtract to give you 30. If you're not familiar with the number 10,800, well, you can start by breaking it up into 108 times 100. Okay. From here, let's break up the 108 into 12 times 9, while we'll break up the 100 into 10 times 10. Okay. And let's check this out, guys. If I multiply 12 times 10, I'll get 120. And then multiplying 9 times 10, I get 90. Well, that gives me two factors of 10,800 that'll subtract to give me 30 now, won't it? Now, of course, you won't magically come up with these numbers here. However, this process does show you the potential of breaking down our larger values to find factors that we need when still trying to use the zero factor property. Once again, check out that video on factoring quadratic trinomials part 3 to master this. So from here, I'm opening up two sets of parentheses, and I'll have my variable x. I'll have 120 and 90. The 120 needs to be positive because that's the sign of the middle term's coefficient. And because we're subtracting, the 90 needs to be negative. From here, we'll be setting each factor equal to 0 and then solving each equation. I have x plus 120 equals 0. X minus 90 equals 0. And then I'll subtract 120 to both sides. This gives me x equals to negative 120. Adding 90 to both sides. This gives me x equals to 90. We'll be rejecting the negative 120 because we're looking for lengths of a triangle, and your triangles in reality don't have negative lengths, guys. So this is an extraneous solution. We cannot use this in the original problem. However, the 90 is just fine. So going back to Jasmine and her big head, we'll have x equals to 90 feet as the horizontal distance, and then that means that our vertical distance is going to be 90 plus 30, which gives us a sum of 120 feet. So that tells us how high this kite is. So that's the answer. Red, box it. The kite is 120 feet high, guys. That is the answer to the problem. And keep in mind that your value of x that you found was just the horizontal distance. It wasn't the answer that they were looking for. So be careful when solving word problems. You want to always be paying attention to what the question is actually asking for. Never assume that your answer for your variable is the answer to the question. All right. Make sure that you're answering the question at hand when solving any type of word problem. And that's problem number 5. Problem number 6 says to find two consecutive integers such that 3 times the square of the first is equal to 7 more than 5 times the second. So when setting this problem up, when dealing with consecutive integers are separated by 1. So since I don't know what the first integer is, I'm going to call that my variable x, while the second integer must be 1 more than the first integer. So we have a setup of x being the first number while x plus 1 being the second number. Applying these values to our word problem, when they say find two consecutive integers such that 3 times the square of the first is equal to 7 more than 5 times the second, you'll end up with this equation here. 3x squared equals 7 plus 5 times the quantity of x plus 1. Keeping in mind that x represents the first consecutive integer and x plus 1 represents the second consecutive integer. Now I'm going to get my arrows popping, people. So we'll have 3x squared equals 7 plus 5x plus 5. I'll then combine my like terms on the right side to get 3x squared equals 5x plus 12. And then I'll be subtracting 5x and 12 to both sides of the equation. Remember, you can do this in 2 separate steps, but I'm a little limited on my space here. So I'm going to take advantage of this. and just do 2 steps in one. I'll then be bringing down 3x squared minus 5x minus 12 equals 0. Once again, I want to write my answer in descending order of my variable x, and in other words, I want to put it in standard form. I'll once again be using the AC method of multiplying the first times the last to get 36, and now I'm looking at factors of 36, which are 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6 to find factors of 36 that will subtract to give me 5. In this case, I can use 4 and 9 as the factors that will subtract to give me 5 and multiply to give me 36. From here, I'm opening up 2 sets of parentheses, setting the equation equal to 0. My variable is x. I'll be using 9 and 4. And because my middle term's coefficient is negative, the 9 needs to be negative and the 4 needs to be positive in order to subtract. Since my leading coefficient is 3, I'll be dividing both factors by 3. Simplifying, I'll end up with x minus 3, and any remaining denominators will go in front of the variable to give me 3x plus 4 equals 0. So this is my equation after the left side has been completely factored. The next thing we'll do is we'll go ahead and set each factor equal to 0 and solve for them separately. That's right. Doing the 0 factor property, guys. I'm adding 3 to both sides of the equation in the first one to get x equals to 3, and then subtracting 4 to both sides of the equation in the second equation. I have 3x equals to negative 4. Divide both sides by 3 to give you x equals to negative 4/3. Now, these are the 2 solutions that we got through our 0 factor property process. However, we're going to reject the negative 4/3. The reason for this is because we're looking for 2 consecutive integers. Well, even though negative 4/3 is a rational number, it's not an integer. Integers are basically the whole number set and their opposites, okay? So since whole numbers don't include these type of fractions, neither do integers. Therefore, the negative 4/3 is extraneous. So what we'll keep is the 3. So because our value of x equals to 3, in order to find out the next consecutive integer, all you have to do is add 1 to that value. So this is going to be 3 plus 1, which equals to 4. So that means that our solution to the problem is 3 and 4. And that's it. Those are the consecutive integers that solve this problem. Red, box it. All right. And that is our solution to problem number 6, guys. Done and done. In problem number 7, the sum of a number and its reciprocal is 13/6. Find all such numbers. So this number that they're referring to, I don't know what that is. Let's call it a variable. X will equal to the number, while 1 over x is going to equal to the reciprocal of the number. Remember, the reciprocal simply means to flip the number, and since x is equivalent to x over 1, when you flip it, you'll end up with 1 over x. Therefore, we have x as the number, and the reciprocal of x is 1 over x. All right, going back to our problem, the sum of a number and its reciprocal equals 13/6. We now have our equation, guys. Remember, when finding the sum, that means we'll be using addition. And because they once again refer to the reciprocal, we'll be using our value of 1 over x to represent that. From here, I want to get rid of these rational expressions, aka these fractions. And I can do that by multiplying each and every term by the least common denominator, which in this case is 6x. So I'll have 6x times x plus 6x times 1 over x equals to 6x times 13/6, like so. If you want to see more examples of solving rational equations, go ahead and check out our video, which is going to be right here. I'll put a link. Thanks. And multiplying this out, you'll have 6x squared plus, here our x's will cancel out to leave you 6. Here our 6's will cancel out to leave you 13x. And now we'll be setting this equal to 0 and putting the equation in standard form. I'll be subtracting 13x to both sides of the equation. This gives us 6x squared minus 13x plus 6 equals 0, people. I'll then be using the AC method. Multiplying 6 times 6 gives me 36. Factors of 36 are 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. The 2 factors that will add to give me 13 are 4 and 9. Yeah, just like that. So from here, I'm going to be opening up 2 sets of parentheses. I'll have my variable x. I'll have 9, 4, and the 9 needs to be negative because it's assigned to the middle term's coefficient. And since I'm adding to get negative 13, the 4 needs to also be negative. Because I have a leading coefficient of 6, I'll be dividing both factors by 6 and simplifying. Simplifying, we have x minus 3/2 times x minus 2/3 equals 0. Any remaining denominators will go in front of the variable. So we'll be writing our completed factor form as 2x minus 3 times 3x minus 2 equals 0. And now we'll be setting each factor separately equal to 0 and solving for x. I hate this 2. I gotta change it up. I mean, come on now. Why are you so ugly? Why are you so ugly? There you go. Better. Cosmetic surgery. We're going to be setting both of these factors equal to 0 and solving for them. We'll have 2x minus 3 equals 0. You'll have 3x minus 2 equals 0. And then solving for x, you're adding 3 to both sides of the equation. That gives us 2x equals to 3. Divide both sides by 2. You'll have x equals to 3/2. Then in the second equation, I'm adding 2 to both sides of the equation. 3x equals to 2. Divide both sides by 3. And x equals 2/3. So our solution set, and let's see if I can get a decent brace going, we'll have 2/3, 3/2, and that will do it for problem number 7. Red, box it. All right, there we go, guys. And remember, when doing your solution sets, write your answer in ascending order. There you go. Yeah, that was number 7. In problem number 8, a rectangular piece of metal has a length that is 4 inches less than twice the width. A square piece 2 inches on a side is cut from each corner. The sides are then turned up to form an uncovered box of volume 256 cubic inches. Find the length and width of the original piece of metal. All right, well, they said a lot. Let's go ahead and create our rectangle. There we go. And now, as we label, we don't know what the width is, but we do know that the length is going to be 4 less than twice the width. So that gives us 2w minus 4. In addition to that, they're going to be cutting out 2-inch squares from here, being cut from our metal piece here. There you go. And keeping that in mind, guys, that means that what remains will look something like this. Let's see if I can construct this. All right, there we go. So they'll be taking out these 2-inch squares from the corners of our original rectangular piece of metal and then folding up the sides to create this uncovered box here. All right, so that means that our width is going to be 4 less than it originally was, because you're going to take away 2 inches here and 2 inches here. So that means that our width of the final uncovered box is going to be the original width minus 4. The same thing is going to apply to the length. We already knew that the length was equivalent to twice the width minus 4, but now you're going to have the additional 4 inches also subtracted from our original length. So that means that we'll now have a length of 2 times the width minus 8. Once again, we already said that the original length was 2 times the width minus 4, but after cutting out those 4 inches, 2 on each side of our length here, you'll end up with 2 times the width minus 8. And as far as the height of this rectangular box is concerned, that's going to be the 2 inches that we had originally cut out, remember, before we started folding things up. So that pretty much gives us a rectangular prism as far as the volume is concerned. And the volume of a rectangular prism is the length times the width times the height, which, by the way, guys, is 256 cubic inches. All right, well, keeping this in mind, we're going to use substitution on our rectangular box here. We'll have a length that is 2w minus 8 times a width of w minus 4 times a height of 2, which equals to 256. From here, I want to get a little crafty and factor out a 2 out of that first factor. We'll have 2 times w minus 4 times w minus 4 times 2 equals 256. Multiplying 2 times 2 will get 4 times the quantity w minus 4 squared, which equals 256. Then, by dividing both sides by 4, you'll have the quantity w minus 4 squared equals 64. This is perfect, guys, for the square root property, which is what I'll be using to solve this problem now. So using the square root property, I'll be taking the square root of both sides. So I'll be taking the square root of w minus 4 squared. And the square root of 64, guys, is 8, while the square root of w minus 4 squared is going to be the absolute value of w minus 4. All right, so some of you guys will be using the shortcut or just writing plus or minus 8 over here on the right side. But I like to show students the reasons why you can use that shortcut as often as possible so you'll be aware of it. Solving our absolute value equation is how you'll end up with that plus or minus 8, guys, because the absolute value is looking for the distance to 0 to equal to 8. Well, that means that I know that I can have a distance of 8 to 0 being originated at -8 or at +8. And that's what gives you your plus or minus 8 value due to the fact that you have an absolute value equation at this point. Solving for each equation now, I'll be adding 4 to both sides of the equation to get the width equals to -4 or the width equals to 12. All right, we want to keep in mind that these are the dimensions to a rectangle, all right, talking about that original sheet of metal. And we're not going to have negative lengths here. So that means that the value of -4 is extraneous. We'll be keeping the width of 12. So looking back at our original diagram, the width is going to be 12 inches, and the length is going to be 2 times 12 minus 4, and 2 times 12 is 24, and 24 minus 4 is 20 inches. So that means that the dimensions of our original rectangle had a length of 20 inches by a width of 12 inches. And that is more fireworks, as well as the answer as we red box it and bring in the new year with a brand new Fort Bend tutoring video, guys. So this concludes our final example for our solving quadratic word problems video. Please go ahead and make sure that you subscribe to the YouTube channel. Please rate, comment, and let me know if this video helped you and your classmates. That would really be helpful, guys, if you leave me that feedback. Peace.
Thanks for watching. We appreciate you hanging out with Fort Bend Tutoring. Like the video, comment, and subscribe. Hit up our website, tutoringmath.net, and set up a private tutorial with me and FBT. Oh yeah, baby.